In this video, I will briefly introduce you to the universe. Our universe was born in a gigantic explosion 13.7 billion years ago. We don't know what triggered the Big Bang and what existed before it. But somehow the universe emerged as a sea of ultra-hot gas, expanding fast in all directions. The Big Bang was not destructive, instead it created everything in our universe. As our universe expanded, its hot gas get cooled. When the gas get cold enough, gravity pulled each high-density regions inward on itself, giving birth to galaxies which are huge clusters of stars and their planets and diffuse gas between the stars. The earliest galaxy was born when the universe was a few 100 million years old. At the center of most very large galaxy, there is a huge black hole, which is million times heavier than sun's weight, or it could be more. The Earth resides in a galaxy called the Milky Way. Most of the Milky Way's stars are in a bright band of light that stretches across Earth's sky on a clear dark night. The nearest large galaxy to our own is called Andromeda. It is 2.5 million light years from Earth. It contains about a trillion stars and is about 100,000 light years in size. The Milky Way is a sort of twin to Andromeda, about the same in size, shape and number of stars. The Earth lies here in the Milky Way. Andromeda contains a gigantic black hole, which is 100 million times heavier than the Sun and as big as Earth's orbit. It resides in the middle of the central bright sphere. Stars are huge, hot balls of gas, usually kept hot by burning nuclear fuel in their cores. The Sun is a fairly typical star. It is 1.4 million kilometers across, which is about 100 times larger than the Earth. Its surface had flares and hot spots and cooler spots, and is fascinating to explore through a telescope. 8 planets, including the Earth, travel around the Sun in an elliptical orbit. Along with many dwarf planets and many comets and smaller rocky bodies called asteroids and meteoroids. Earth is the 3rd planet from the Sun. Saturn with its ring is the 6th planet. The solar system is 1,000 times bigger than the Sun itself. Light needs 11 hours to travel across it. Proxima Centauri is the nearest star other than the Sun, which is 4.24 light years away from Earth. The Sun and Earth are about 4.5 billion years old, which is about 1/3 of the age of the universe. From now, after another 6.5 billion years or so, the Sun will exhaust the nuclear fuel in its core, the fuel that kept it hot. The Sun then will shift to burning its fuel in a shell around its core, and its surface will expand to engulf and fry the Earth. As the shell's fuel spent and the Earth fried, the Sun will shrink to become a white dwarf star, which is about the size of the Earth, but with density 1,000,000 times bigger. Stars much heavier than the Sun burns their fuel much more quickly and then collapse to form a neutron star or a black hole. Neutron stars have masses about 1 to 3 times that of the Sun and circumferences of 75 to 100 km, which has same density as nucleus of the atom. Black holes are made from wrapped space and time. They contain no matter, but they have surfaces called event horizons or just horizons, through which nothing can escape, not even light. That's why they are black. A black hole circumference is proportional to its mass. The heavier it is, the bigger it is. A black hole with about the same mass as a typical neutron star or white dwarf, which is 1.2 times as heavy as the Sun, will have a circumference of about 22 kilometers. Since stars are generally no heavier than about 100 suns, the black hole to which they give birth are also no heavier than 100 suns. The giant black holes in the cores of galaxies are millions to 20 billion times heavier than the Sun. Therefore, these black holes cannot have been born in the death of a star. They must have been formed in some other way, perhaps by the collisions of many smaller black holes, perhaps by the collisions of massive clouds of gas. Neutron stars have very strong magnetic fields. whose force lines are donut shaped like the Earth's magnetic field. Fast moving particles trapped in a neutron star's magnetic field and produce the blue rings. Some of the particles are liberated and streamed out of the field's pole, producing two violet jets. These jets consist of all types of radiation: gamma rays, X-rays, ultraviolet, visible, infrared and radio waves. As the star spins, its luminous jets sweep around the sky above the neutron star. Like a searchlight, every time a jet sweeps over the Earth, astronomers see a pulse of radiation. So astronomers have named these objects pulsars. The Earth's gravitational force lines points radially into the Earth and they pull objects toward the Earth along themselves. The strength of the gravitational pull is proportional to the density of the force lines. As they reach inwards, the force lines passes through the sphere of ever decreasing area, so the line's density must go up inversely with the sphere's area, which means the Earth's gravity grows as you travel towards it as 1 over the red sphere's area. Since each sphere's area is proportional to the square of its distance r from the Earth's center, the strength of the Earth's gravitational pull grows as 1 over r square. This is Newton's inverse square law for the gravity, and the gravity penetrates everything and holds the galaxies together. So this is the end of this video. I hope you got the brief introduction to the universe.